Welcome back to Math Solver 1117, the place where maths become simple. In today's video, we are diving into a super important topic, that is derivative of trigonometric function, especially sine function and cosine and tangent. Before we jump into formulas, let's answer a quick question. Why do we even need derivatives of trigonometric functions? We need trigonometric functions derivative in real life, mostly in the questions in numericals of physics, in engineering, and even in economics and machine learning. In these, we need derivative and especially trigonometric functions derivatives. So, we will start how to differentiate sine, cosine and tangent, and I will make a model for you to solve real problems. First of all, we will start from sine function. Now, first of all, we will study the derivative of sine. So the derivative of sine is find out by d by dx of sine x, that will be equals to the cos of x. And you will remember this by consider a curve or imagine a wave. This is a wave and the slope of this is the slope and that will be the cos. So you will easily realize that when you draw a wave, slope of a sine curve is cos. Now we will find the derivative of a function like you have f of x equals 3 sine x. So when you have to find the derivative of sine, you have to remember the formula, that is derivative of sine x is cos x. So you will differentiate this and d by dx into 3 sine of x. So 3 is constant, so it will be taken as common, and the differentiation of sine is cos x. So 3 cos x will be the answer. Now if another example is find the slope of, you have to find the slope of y equals sine of x at x equals to 0. So you will find the slope. First of all, you will differentiate the given function. So dy by dx equals d by dx of sine of x, that is equals cos x. So at x equals 0, it means cos of 0, that we know equals 1. So the slope equals 1. Now we will study the derivative of cos x. So the derivative of cos x is as d by dx of cos of x equals negative of sine of x. Notice the negative sign, it's a super important. So you have to remember that if that cosine leads to negative sign like a drop in a curve. So now we will solve another example to elaborate this concept. You have a given function f of x equals 5 cos of x. You have to differentiate this, so f dash of x will be equals 5 is d by dx of 5 cos of x. 5 is taken as common, so 5 minus sin x. You will write this as minus 5 sin x. So this is the derivative of cos x. Now we will do another example. Let's suppose you have a function y equals cos of x. So find slope at x equals pi by 2. Pi by 2 means 90 degree. So you will solve this as, first of all, find dy by dx, d by dx of cos of x. So cos of x equals minus sine of x, so minus sine of x. So at x equals pi by 2, you will get minus sine plus pi by 2. Sine pi by 2 means sine 90 degree, that is equals to 1. So minus 1. This is the slope. So the final answer is minus 1. Now we will solve the derivative of tan x. Now the derivative of tan x is find out by this formula, d by dx derivative of tan of x equals the secant square x. So mostly students ask why secant square x, because we know that tan of x equals sin x by cos x, and here we apply the formula of quotient. Quotient rule apply in this. So according to quotient rule, when we find the d by dx of this and d by dx of sin x by cos x, so by quotient rule we will solve this as, so this will be equals cos square x, and then cos of x, and the derivative of sin x is cos x minus derivative of the second function cos x is minus sin x, and the first function as it is sin of x. So you get cos square x, and minus minus will become plus, plus sin square x divided by cos square x. So sin square x plus cos square x equals to 1. This is the first identity. So you get 1 over cos square x. So you know we have studied that cos square x is the reciprocal of secant square x. So 1 over cos square x equals secant square x. That's why we get the derivative of tan equals secant square x. Now we will solve this as given function y equals 2 tan of x, and you have to find the dy by dx means d by dx of 2 tan x. Its mean 2 into differentiation of tan x is secant square x. 2 is as constant, so answer is 2 secant square x. Now we have another example. Example is find the slope of you have to find the slope of tan x at x is equals 0. So dy by dx of tan x equals secant square x. So at x is equals 0, you will get secant square equals 1 over cos square x. So 1 over cos 0 is 1, it's mean 1 over 1, that is 1. So slope is 1. So this is the final answer. Now I will draw a table. Now here is a table. You can pause and take the screenshot of this table to remember this, because this table is very important for your further study of derivatives of trigonometric function. So here we write the functions and here we write the derivatives. So we have the first function is sin x. So write the sin x, and the derivative of sin x we have studied is cos x, and the derivative of cos x is the negative of sin x, and the derivative of tan x is secant square x. Here is a bonus question. F of x equals sin 3x. Now you have to find the derivative of this and tell us in the comment section. If this video helped you, make sure to like the video, share with your classmates and subscribe Math Solver 1117 for more easy maths lesson. Hit the bell icon so you never miss out. Best of luck for your exam. Stay tuned.